7.2 WAN Operations 7.2.1 WAN Standards. Now that you understand how critical WANs are to the large networks, this topic discusses how they work. Modern WAN standards are defined and managed by a number of recognized authorities, including the TIA-EIA. They are the Telecommunication Industry Association and the Electronic Industry Alliance. Also ISO, that's the International Organization for Standardization. IEEE, that's the Institute of Electrical and Electronics Engineers. Most WAN standards focus on physical layer and the data link layer, as shown in the figure here. Layer 1 protocols describe the electrical, mechanical, and operational components needed to transmit bits over a WAN. For example, service providers commonly use high bandwidth optical fiber media to span long distance, using following Layer 1 optical fiber protocol standards: the Synchronous Digital Hierarchy, the SDH, Synchronous Optical Networking, the SONET, the Dense Wavelength Division Multiplexing, the DWDM. Layer 2 protocol defines how data will be encapsulated into a frame. Several Layer 2 protocols have evolved over the year, including following: the broadband, wireless, Ethernet WAN, multi-protocol label switching, point-to-point protocol, high-level data link control, frame relay, and asynchronous transfer mode. The WAN physical layer describes the physical connections between the company network and the service provider. There are specific terms used to describe WAN connections between the subscriber and the WAN service provider, as shown in this figure. They are the data terminal equipment, the DTE, the data communication equipment, DCE, customer premises equipment, CPE, the local loop, cable junction box, CO switch, enterprise edge, service provider edge. 7.2.4 WAN devices. There are many types of devices that are specific to WAN environments. But the end-to-end data path over a WAN is usually from source DTE to the DCE, then the WAN cloud, then to the DCE, and finally to the destination DTE, as shown in the figure. 7.2.5 Serial communication. Almost all network communications occur using a serial communication delivery. Serial communication transmits bits sequentially over a single channel. In contrast, parallel communication simultaneously transmits several bits using multiple wires. Now let's talk about parallel and serial communications. For parallel communication, it sends multiple bits at the same time over multiple channels. In theory, this can transfer more data at once. However, over a long distance, the bits may arrive at slightly different times. This is called a synchronization or timing problem. Because of the limitation, traditional parallel communication over copper is generally suitable only for short distance, not WAN connections. And then the serial communication, in contrast, sends bits sequentially over a channel. It's much more practical for long-distance WAN communication. Parallel transmission can still be useful over short distance and a specialized high-speed environment. For example, the data center can use parallel optical lines to achieve very high aggregate speeds. A circuit switch network creates a dedicated connection between two endpoints before communication begins. Think about a traditional landline telephone call. So the caller requests connection, and then the telephone provider establishes a circuit. The caller and the receiver has the dedicated circuit, so the conversion begins. And then the call ends, the circuit is released. The important point is that the circuit is established before voice and the data is transmitted. During transmissions over a circuit switch network, all communication use the same path. The entire fixed capacity allocated to the circuit is available for the duration of the connection, regardless of whether there is information to transmit or not. This can lead to inefficiency in circuit usage. For this reason, circuit switching is generally not suited for data communication. The two most common types of circuit switch WAN technologies are the public switch telephone network, the PSTN, and the legacy integrated service digital network, ISDN. 7.2.7 Packet switch communications. Network communication is most commonly implemented using packet switch communication. In contrast to circuit switching, packet switching segments traffic data into packets that are routed over a shared network. Packet switch networks do not require a circuit to be established, and they allow many pairs of nodes to communicate over the same channel. Packet switching is much less expensive and more flexible than circuit switching. Although susceptible to delay and the variability of delay, modern technology allows satisfactory transport of voice and video communication on these networks. The common types of packet switch WAN technologies are the Ethernet WAN, the multi-protocol label switching, also the legacy frame relay, and the legacy asynchronous transfer mode. 7.2.8 SDH, SONET, and DWDM. Service provider networks use fiber optic infrastructure to transport user data between destinations. Fiber optic cable is far superior to copper cable for long-distance transmissions due to its much lower attenuation and interference. There are two optical fibers OSI Layer 1 standards available to service providers. The SDH, also the SONET. SDH stands for Synchronous Digital Hierarchy. It is a global standard for transporting data over fiber optic cable. And for SONET, it stands for Synchronous Optical Networking. It's the North America standard that provides the same services as SDH. Both standards are essentially the same, so they are often listed as SONET/SDH. SDH SONET define how to transfer multiple data, voice, and video communications over optical fiber using lasers or light-emitting diodes over great distance. Both standards are used on ring network topology that contains a redundant fiber path that allow traffic to flow in both directions. Dense wavelength division multiplexing, that's the DWDM, is a newer technology that increased the data carrying capacity of SDH and the SONET by simultaneously sending multiple streams of data using different wavelengths of light as shown in the figure.